Hello, welcome to another session of our Easy channel. Today we're going to dive into a new type of data that is chromatography data. And before we start, as always, if you like this video, please press the like button and feel free to share with your colleagues, your friends. If you know of any other topics you would like me to discuss, especially in like how to use ChatGPT to do certain kind of data analysis or data visualization, make sure you comment that in the comment section of this video. And last but not least, if you're interested in the full transcript of my chat with ChatGPT in this session, also make sure you leave an email address at the comment section of this video. And with that, I'll start the journey today. So today we're going to talk about a new type of data that's chromatography data. And you can find a more detailed discussion of this Jupyter notebook in the GitHub repo called DV4C. I'll share the link in the description section of this video as well. But for today, we will focus on two plots actually. And that's because we have already covered how to generate a line plot in our first session in the mass spec plotting part. And we actually will focus more on how to do a little bit of the data manipulation of our of the raw data we will download, and to allow us to generate insightful plots from them. So the first plot we'll try to replicate is actually this one. So if you read through the session in this Jupyter notebook, it's basically discussing that you might get off-the-shelf or say wonder software for after running a liquid chromatography to get a overlay plot like this. However, this is not the easiest to compare purity across samples, especially if you know that the main peak represents the desired product in your chromatography. However, in this very easy, as we'll see, change of the axis into only plot relative to the highest peak you find in the chromatogram, it will convert what we saw above into this new overlay plot, which now is a lot easier for scientists to visually compare the purity of the samples. And obviously, in this case, the sample 3, represented by the red line, has the highest purity. So we'll start from this one. And as always, you can find the raw data in the same folder of the DV4C GitHub repo. And we'll start with this one. And in our case, we actually have already downloaded both CSV file we'll use for today's session. And we'll jump right in. As always, we'll start a new Jupyter notebook for today's session, and let's call that LC data visualization. And we'll open our favorite AI tool, in this case, ChatGPT. And let's see. We covered how you can actually examine CSV files in Python in one of our earlier sessions. If you haven't checked it out, make sure you check it out here. But with that, I'll just basically skip that part and just dive into, it's not what I want, dive into the CSV file format. So here, as we can tell, for our first case, actually, let me add in a header here. So this is overlay case 1. In our first case here, we have 3 columns, right? We have time, as expected for most of our chromatography data. The x-axis is retention time. This is the UV signal, and we have sample. And because this is, the example data for the first case scenario, we can expect that we actually have 3 samples in this CSV file. And as always, we can confirm that by asking Python to display that. So indeed, we have 3 unique samples. Now we get a hold about our data structure. We can ask ChatGPT to help us generate a plot. I have a CSV file with 3 columns. We have time, UV, sample. There are 3 unique samples in this CSV file. I would like to first of all generate a new column named relative time, which is centered around the which is zeroed by the highest UV value per sample. And then I would like to plot the entire CSV file with relative time as x-axis and UV as y-axis. Okay, actually, yeah, I think this is the paid version of ChatGPT. It can generate a plot for us, but we will probably be more interested in the codes. So let's do that. And I already write in this CSV file as this data frame as the name of df. All right. Now let's see whether this works. Yep, that already worked. And as you can tell, it's pretty much the same as what we got here with different color coding, obviously, and different x-axis limit. We have talked about in the earlier sessions about how you can change the x limits. But in case you want ChatGPT to do that, you say, "Can you give me the line to change the x limit to?" I think we want from -5 to 5. Yep. And this is all we need. So we can throw that anywhere before we show the plot. If we play here, that's exactly what we got. So this is easy peasy, right? Now we can jump to our second case example, which is slightly more complicated than the first one. So I'll make sure that I put my Jupyter book more nicely. I can basically hide all 3 cells there. So here is in another application case where we have 3 conditions. This could be different chromatography conditions. And per condition, we run 3 samples. So sample 1 to 3. I don't think the legend's correct here. because it didn't quite match what was described here. So the idea is that these different conditions will give different resolution among the three samples, and we want to have a easier way to visualize and compare the resolution, such as shown below. And as you can tell, in this case, we actually generate three subplots, and in each subplot represents one condition. So we have one condition 1, 2, and 3. And in each condition, the x-axis is centered around the retention time of our sample 2. So in this case, it's a lot easier for us to say that as we go from condition 1 to 3, the resolution among these three samples are actually increasing. So how can we use ChatGPT to help us generate this plot? So for us to do that, and as a reminder, again, the raw data we're going to use will be this one. And we need to get a flavor of what a raw data looks like. Okay, as we can tell here, this is the top 5 rows in our in the example data for our second overlay case. And compared to our first overlay case, if you still remember, there's now an additional column called condition. And we can take a quick look at the correlation between samples and conditions. And in case you don't know how to do that, we can ask ChatGPT to help us. So we can say in another scenario, I have a pandas data frame named df with 4 columns, right? So we have time, UV, sample, condition. How can I figure out how many samples, or actually, what are the samples in each condition in this CSV? All right, so in this case, the ChatGPT is instructing us to use group by function, and it then basically format the group by results better for us to read through. But as shown here, clearly we have 3 conditions, and per condition we have 3 samples. So this match what we saw here, and we just need to tell ChatGPT how we want to plot this one. So I have samples 1, 2, 3 in each condition, and in total 3 conditions. Condition 1, 2, 3. I want to plot each condition in this subplot, and within each condition, I want to center the actually each sample by the highest UV peak observed in sample 2. All right, I think this are all the plots we need. So let's copy that. Try this. Okay. So if you are familiar with Python, you probably notice what's wrong here. But let's see whether ChatGPT can figure this out. Okay, so I think in this case, we cannot just blindly copy the code. We actually need to read through what ChatGPT told us. Instead, this error occurs because after we filter for the sample equals to 2, this result is actually empty. So, and we know this is not right because when we look at here, our sample names are actually sample 1, sample 2, instead of just 1 or 2 here. So we might get more accurate result faster if we tell that to ChatGPT. In the sample column, my sample names are sample 1, sample 2, and sample 3. All right, let's try this again. I don't think ChatGPT realized what's happened here. This will be hard to resolve if without any knowledge about Python. But based on my experiences, what's happening here is that because we select the sample2 data in this way, the index in the sample2 data actually didn't start from 0. So when we later try to call out the sample2 peak time using a .ilog function, that's when it mostly broke. A quick fix, usually in my case, is if we just reset the index here. And as you can tell, that actually works. So this reset index fixes this issue. So now we generate a plot similar to what we have here. Something we want to fix is probably the x-axis range, as we've seen before. And in this case, let's ask ChatGPT. How do I change the x-axis range to, how much do we find? All right, -8 for each subplot here. Just give me the single line to do the change. Okay, so if we do this, now we're in the proper x-axis range. Obviously, this doesn't look as beautiful as we have here, but this could be a good homework for you. Can you figure out how to change, or with the help with ChatGPT, to change the aspect of the plot to make it more compact? And with that, we comes to the end of our session today, and I hope I show you that ChatGPT can help you to manipulate your, or actually to change your LC data a little bit so that it give you more straightforward visualization to answer specific type of scientific questions you have in mind. If you like this video, again, please press that like button. Please share that with your friends and colleagues or whoever you think might be also interested in these topics. And also subscribe to our channel so that next time when your video comes up, you will get a notification. With that, thank you all for being here today, and I'll see you in another session.